Alright, welcome to the AI Research Roundup. I am Alex. Today is June 7th, 2025. We're looking at SeedVR2, one-step video restoration via diffusion adversarial post-training. This paper, from Hugging Face's trending list and published just 2 days ago, tackles the slow speed of current video restoration. It builds on diffusion models, which clean up video by reversing a noise process. SeedVR2 aims for high-quality restoration in a single step using adversarial post-training, which refines a pre-trained model by making it compete to produce realistic outputs, alongside an innovative adaptive window attention mechanism. Okay, so this first figure really sets the stage. We see a vibrant image of a dragon dance from a video, with zoomed-in sections comparing restoration quality. These show SeedVR2 clearly enhancing fine details better than other methods. Then, there's a scatter plot. This compares runtime against LPIPS. LPIPS, or Learned Perceptual Image Patch Similarity, measures how close the output is to an ideal image perceptually. The plot also considers model parameters, indicating model size. Both the 3 billion and 7 billion parameter SeedVR2 versions show superior speed, over 4 times faster, and excellent visual results. Building on that speed and quality, this next diagram details the model's architecture. We see 2 main parts: a generator, which creates the restored video, and a discriminator, which helps train the generator. The discriminator uses an RPGAN loss for stability and a feature matching loss. This feature matching loss compares internal video features extracted from specific layers of the discriminator. A key innovation shown is the adaptive window attention. This mechanism cleverly adjusts processing windows based on video resolution, preventing boundary artifacts and ensuring it works well with various real-world inputs. This table then provides a quantitative comparison, showing how the one-step SeedVR2 models stack up against existing methods. It looks at visual fidelity, which is about detail accuracy, visual quality, referring to perceptual clarity, and overall quality, with percentages indicating relative performance. Here, the proposed 7 billion parameter one-step model, ours 7B1, serves as the baseline. Interestingly, ours 3B1, the smaller 3 billion parameter one-step version, shows a plus 16% improvement in both visual and overall quality compared to this 7 billion parameter baseline. This highlights the efficiency and strong performance of the smaller model. Alright, so this table really digs into the performance with hard numbers. We're looking at quantitative comparisons across diverse video restoration benchmarks, including synthetic ones like SPMCS and real-world data like Video LQ. The metrics assess different quality aspects. For instance, PSNR and SSIM. These gauge detail accuracy and structural similarity, respectively, where higher scores are better. Then there's LPIPS, and a similar metric DISTs. These focus on perceptual clarity, so lower scores are preferred. Looking at the results, the SeedVR2 models, ours 3B and ours 7B, consistently achieve top scores, marked in red and orange, particularly excelling in those perceptual measures. So, to wrap things up, the strong performance of SeedVR2 on these benchmarks really underscores its capabilities. The key takeaway here is that SeedVR2 successfully tackles the high computational cost of traditional video restoration, making high-quality, detailed video enhancement possible in a single step and significantly faster. This is achieved through smart innovations like adaptive window attention and progressive distillation. It's a big step forward for real-world video restoration. That's all for this AI Research Roundup. Thanks for tuning in.